Friends, today's subject of discussion is synthesis of Celecoxib. Celecoxib structure is like this, as we have shown here. The basic ring which is there in Celecoxib is pyrazole. At one position, it has been attached with parasulfonamidophenyl group, and at fifth position, tolyl group is attached, and at third position, trifluoromethyl group has been attached. Celecoxib can be prepared by cutting this molecule like this. This part can be a parasulfonamidophenyl hydrazine. I can take as a starting material, and this part I will cut. A 2 carbon donor I have to take, and a tolyl ethyl group. If these three parts I combine together, I can get Celecoxib. Before going to the synthesis, let us look into the utility of the Celecoxib. These are selective COX-2 inhibitors. Means it do not have any inhibition on COX-1 enzyme. As we know that all the NSAIDs are having the side effect of ulcerogenicity. This has been attributed to COX-1 inhibition. Hence, to overcome that, selective COX-2 inhibitors have been developed. Celecoxib is one of them. That's why it is classified as non-ulcerative NSAIDs, non-steroidal anti-inflammatory drugs. But however, Celecoxib also has side effects which is known as sudden death syndrome. Continuously if you use, it causes sudden death. This is an attributed to because of the heart attack. Some of the coxib derivatives have been banned because of this side effect. Thus, celecoxib should be used with caution under the prescription of the doctor itself. It should not be used irregularly. Let us look into the synthesis. I have to take a 2 carbon donor and attach it with a tolyl with ethylene group. This part if I want, I'll take paramethyl acetophenone. I'll take paramethyl acetophenone and treat with a strong base like sodium hydride. It's so strong and is acidic enough to lose the proton due to the adjacent electron withdrawing group, which is the carbonyl here. It is acidic enough to lose the proton and is basic enough to abstract the proton. It abstracts the proton from here, and the proton, hydrogen, loses as proton, leaving the electrons onto the carbon, and it gives rise to a carbene ion generation. The carbene ion which is formed is highly unstable. I'll react with 1,1,1 trifluoroethyl acetate. It is the carbonyl carbon. This carbonyl carbon is flanked between oxygen and CF3, the two electron withdrawing groups, thus renders this carbon as an electrophilic center. Is an electrophilic center and is an electron rich carbon, that is carbene ion. Unlike poles attract each other, and this way these electrons are shared with the carbonyl carbon, and ethoxy group gets kicked off as it's an easy living group. I got corresponding trifluoroacyl group attached to the acetophenone group. Now, this molecule is treated with the another part, the parasulfonamido phenyl hydrazine. The lone pair of electrons on the nitrogen makes it electron rich. The carbonyl carbon over here is electron deficient due to the electron withdrawing group CF3 and oxygen attached to it. Unlike poles attract each other, lone pair of electrons are donated to the carbonyl carbon, and it has to maintain its tetravalency, and hence the pi electrons moves on to the oxygen and it gets converted into OH, and I'll get the bond between the carbon and the nitrogen. This has amino group which is having lone pair of electrons, and here there is a carbonyl group. The carbon is electron deficient center, and here there is OH and H. When I heat it strongly, the nitrogen and hydrogen bonds, these electrons moves onto the carbon, and OH gets kicked off. H plus and OH minus loses as water molecule, and a double bond is formed between carbon and nitrogen. The lone pair of electrons on the nitrogen attacks on the carbonyl carbon as it is an electron deficient center. Pi electrons moves onto the oxygen and becomes OH, and cyclization takes place. A double bond is between C and N, and cyclization has occurred. Now it undergo aromatization for its stability. The carbon hydrogen bond breaks, and thus electrons are utilized to form the double bond on the adjacent carbon. Once it forms the bond, this becomes pentavalent. It has lost its valency. That's why it has lost its stability. To regain its stability, OH gets kicked off. H plus and OH minus combines together to lose as water molecule, and cyclization occurred already, and a double bond is formed, and aromatization has occurred now, and I have got Celecoxib. This is the preparation method for Celecoxib. Celecoxib is a boon as it is a selective COX-2 inhibitor. It is a non-ulcerative NSAID. However, it is having some drawbacks. That's why it should be used with caution under the guidance of the doctor. Next class, let us deal with other perazole containing drugs. Till then, have a nice day. Thank you.